Okay, now we're going to find the area of a regular polygon. Basics of it is we're going to make an isosceles triangle and find the area of that triangle, and then find the area of the polygon from that. Now the reason why you're going to use an isosceles triangle is I'm going to go to this picture here, and we're generally not going to give you a picture, so this is just to get us started. But if it's a regular polygon, and we can only do this if it is a regular polygon, then that means that all of these sides are the same. And if I draw in the radii, now remember the radius is from the center to each of the vertices. Okay. And what it forms, and since these are all the radii are exactly the same, it forms as congruent triangles. And the number of congruent triangles is equal to the number of sides. So if I knew how to find the area of this one, then I know the area of all of them, and I can find the area of the polygon. And that's the main goal, is to find the area of this one triangle. Alright, so I'm going to just draw this triangle over here. And that's all you need, is one triangle. You don't really need the labels on there, but I'll put them in for this time. And then the apothem, remember, goes straight from the top. It forms a 90-degree angle. And it also cuts that base in half. So we know that the distance from C to D is 12, because that's given to us, which means C to B is 6, and B to D is also 6. Now if you remember, the area of a triangle is 1/2 base times height, or also you could look at it as base times height divided by 2. It does not matter. So we already have the base, and that's 12. Now we need to find the height. So that would be right here. That's the apothem, and I'm going to mark that as x. Now to do this, we can't use Pythagorean theorem because we don't only have one side length, so we're going to need to find an angle. And the easiest one to find is this one up here. We're going to find that big angle up there. Now if I go back to my picture, that's this angle, and if I take that with all of the ones around here, I'm going to actually form a circle. So all those angles added together are going to equal 360. So first thing I'm going to do is to find the angle. I am going to do 360 divided by n. In this case, n is equal to 8. So it's going to give me 45 degrees. But that's the large angle. I only want this part of it. So just like the apothem splits the base in half, it also splits that angle in half. So then I'm going to take that, step 2 is to take that large angle, and we're going to divide it by 2. And that gives me 22.5 degrees. Okay, so this angle right here is 22.5 degrees. Now I can use my trig to find the height. So where this angle is, this is the opposite, x is the adjacent. So step 3 is going to be find the height or base. Depends on what we have. It doesn't matter whether it's this one or in front. So you're going to find the base and the height. So this one, I'm going to use the tangent of 22.5 equals 6 over x, cross multiply. Okay. And then solve for x. And we're almost done. Okay. So, I'm going to clear this. So 6, hold on, I just saw what I did here. I didn't divide it. You're supposed to divide, so let me get rid of all this. and I get x equals 6 divided by tangent of 22.5, and that's 14.4852. So that's the height of our triangle. The next step is to find the area of the triangle. And that's 1/2 times the base, which is 12, times that height we just found. All right. Put this in our calculator. 0.5 times 12 times 14.4852, and that gives me 86.9112. And the last step is, now that we have the area of the triangle, we just take that times the number of sides to get our area of polygon. So 86.9112 times, and there's 1, 2, 3, 4, 5, 6, 7, 8. So times 8 gives me, so I'm just going to go times 8, 695.2896. So we're basically going to repeat this process for all of them. And depending upon what you're given first will depend upon step 3, what you have to find. But the rest of it is pretty much the same. Alright? Okay, let's go to number 2. So number 2, we have another octagon. This time we have a radius. So I'm going to start with my picture. I'm going to draw my triangle. The radius is 9, so that's this side out here. So I don't know the base or the height. I'm still going to draw in the apothem. Actually, I'm going to make this bigger. Well, give me a second here. Just so that we can see it better. This is 9. I'm going to still draw in that apothem. And that's going to split this base. So when given the radius, we do not have either of the base or the height of our triangle. So that means we need to find this length, and we need to find this length. Alright, so the first thing, we got to find the angle at the top. So we're going to octagon n is equal to 8. So we start by taking 360 divided by 8, and it's 45. That gives us the large angle. And then we're going to divide that by 2. Okay. Alright. So now that angle's 22.5. Now I'm going to use my trick to find x and y. So to get x first, this is opposite. The 9 would be the hypotenuse, so that's going to be sine of 22.5 equals x over 9. So I get 9 times the sine of 22.5 equals x. Pull out my calculator. 9 times the sine of 22.5, and it gives me 3.4441 is equal to x. Now to get the full, because that's only part of the base, to get the full base, I'm going to times that by 2. .8883, and the 3 comes from, is, if you look at the calculator, it was a 5 afterwards. It just the calculator will take the whole number times 2, so it might look a little different than if you had just done it in your head. Either one's fine. Okay, so now we have the base. Let's find the height. So the y is the adjacent, the 9 is the hypotenuse, so that's cosine. So the cosine of 22.5 is going to equal y over 9. So that's 9 times the cosine of 22.5 equals y. Okay, I'm going to push this over to the other side. 9 times the cosine of 22.5, and that's 8.3149. Now we have enough to find the area of our triangle. And that's 1/2 times our base, which was a 6.38883. It's still on my calculator. It's right here. It's the second line up. Times the 8.3149. Okay. And that gives me an area of 28.6377. And then to find the area of the polygon, equals, take that 28.6377 times the number of sides. And that's 229.1016. Alright, so there is the area of that polygon. Alright, now to the third one. Calculate the area of a regular hexagon, so that's n is equal to 6. And this time it's the apothem is 5. So let's draw our triangle. Alright, so the apothem is the height that goes straight down. So we're given that. So we have the height of the triangle, we just need to find the base. So I'm going to mark this as x. Start again, find our angle at the top. So 360 divided by 6 is 60 degrees. Divide that by 2 is 30. So this is 30. Alright, so here's the opposite. The height is 5. Or excuse me, the adjacent is 5, so that means tangent. So the tangent of 30 equals x over 5. Cross multiply, and I get 5 times the tangent of 30 equals x. 5 tan 30, and that's 2.888. Oh, sorry. I was thinking the other one. Oh, look, too many 8s. 8.867. But again, to find the base, we're going to times that by 2. .8867 times 2. And that gives me an area of 5.7734. Okay. Or a base of 5.7734. Now, to get the area of our triangle, I'm going to move my, hold on here. I'm going to move my calculator off to the side. Equals 1/2 times my base times the height of the triangle, which is 5. Now I'm going to pull my calculator out. I'm going to move it over to the other side. 0.5 times 5.7734 times 5. And it gives me an area of 14.4335. And then the area of my polygon is the 14.4335 times the number of sides, which is 6. So times 6, and that gives me the area of 86.601. Alright, so that's how you find the area of a polygon. If you have any questions, please let me know.